Alright, ladies and gentlemen, we are going to start another video, how to find zeros, asymptotes, and holes. So if you are confused, get ready because we're going to figure out what's going on. Alright, holes. Okay, holes are when you basically cancel out something on the top and bottom of a fraction. So let's look at what we have here. Okay, you can read the proper definition up above, but I'm going to explain it in my own words. Okay, this thing right here, it looks like we can cancel some stuff out, like x squared and x squared, but we can't, okay, because they're part of the polynomial on top and on bottom. So what we need to do is factor it, okay. The top factors into x minus 3 and x plus 1. Okay, if you need to review factoring, go back and do that now before you jump into this. Okay, in the bottom, we're going to pull an x out, and what we're left with is x minus 3. Okay, with all that done, what we have on top and bottom is a pair of x minus 3's. So what we're going to go ahead and do is just cancel them off. Okay, when you do this, that's when you have a hole. Okay, a hole, like we just said, was when the top and bottom cancel out. Okay, they have to be the exact same thing. Now, a hole is at a zero or at a value for x. So what we have to do is set the x minus 3 equal to 0 because we got to solve for 0. Okay, so we're going to add 3 to both sides, so x is 3. Now, what that means is when you have a graph, okay, let's go ahead and create a little one for you so you can see what we're talking about. Here's x is 1, 2, and 3. Alright, let's say we've got something, let's just say it looks like this, okay? Now normally we'd have a straight line, okay? But now when we have a hole, we get a little different story going on. So let's get rid of that, and let's draw it again. Okay, now we're going to make our line, but when we hit 3 at x equals 3, we have a hole, meaning we have an open circle. Okay, our line, we jump over that point when x is 3. Okay, so when you're creating these graphs or when you're identifying, if you see an open circle, it means a hole, so you have to have a top and bottom of the same thing on your fraction. Okay, so let's look into the next thing about zeros. Okay, with zeros, you must find the holes first. Okay, so let's go ahead and factor this one more time to x minus 3 and x plus 1 divided by x times x minus 3. Alright, now, why do you have to do the holes first? Well, let's talk about it. Okay, zeros, what they are, is only on the numerator of your fraction. So on the bottom, the x times x minus 3, we can ignore that for now. Okay, that's the awesome part. Now, what we have are two things, x minus 3 and x plus 1. Normally, they would be our zeros, and we'll talk about what they are in just a second. But, like we just had before, was a hole. And holes overrule zeros, okay? So the hole is at 3. We just said that. Now, the 0 is what's left over on the top. So the x plus 1, all right? We have to set that equal to 0 as well, because this is at a point. And what we mean by 0 is the x-intercept, the root, where it crosses the x-axis, okay? So x plus 1 equals 0. Solve for x by subtracting 1 on both sides, so x equals negative 1. Alright, so what you need to do is note that a hole versus a 0, okay? Let's take a look at the graph before we jump into that, okay? No big deal. So, what we mean at negative 1, here's x equals negative 1. If I had a line, it would simply just cross at negative 1 right here, okay? Now that's not a hole, so let's get rid of that. Remember, open circles mean holes. Alright, so simply put, zeros are just x-intercepts, okay? But, hole versus 0. What if you have, like we have right here, what if you have x minus 3 times x minus 3 divided by x minus 3? Well, if you cancel one of those x minus 3 pairs out, that's your hole. But then you're thinking, well, I've also got this 0 right here at 3 as well. Okay? No. Like we said, holes overrule zeros. So, essentially, it would be the same thing as an x-intercept, but it actually crosses and jumps over the x-axis and keeps going, just if you're wondering. Alright, we got one more thing to talk about, and that is your vertical asymptotes. Okay, let's go ahead and factor this one more time before we even start, because that is just something we have to get used to. Oh, I have horizontal asymptotes today too? Oh man, she'd make me do all the work today. Alright, x minus 3 and x plus 1 divided by x and x minus 3. Okay, like we said, cancel off our whole. We have our 0 at -1, but now vertical asymptotes are like the opposite of zeros. Instead of worrying about the numerator, we only worry about the denominator. Okay, so what we have left on the denominator is just this x. Okay, now just like everything else, we need to set it equal to 0 so we can solve for what x is. Well, x equals 0, and we're done. Okay, we don't have to do anything. 0 is our vertical asymptote. Okay, now an asymptote is, like we've learned before, it's a line that your function will approach but never cross. Okay, so if we created something real quick just so you can see what it is, let's say we had a vertical asymptote at like 1, 2, 3. Let's say we had a 3. Okay, vertical asymptote would be a dotted line going up and down. And our function, whatever, it would just get really close to this line. It would never cross. It would just kind of run right next to it. Okay, and you might see it come from the bottom over here too. Okay, but that's a vertical asymptote. It'll never cross that dotted line. Now, let's take a look at a special case. Okay, so what if you have a hole and a vertical asymptote at the same time? So right here, okay, x minus 3 divided by x minus 3 times x minus 3. Well, cancel them off, okay? So you think you have your hole at 3, but then like we have before, we look at the denominator, and right here is our vertical asymptote, also at 3, okay? Vertical asymptotes beat holes this time, okay? So hole does not exist, all right? Our graph would have an open circle, but we're never going to cross that open circle because our vertical asymptote is there first. Okay, so keep that in mind as you go through these. Now, those are just special cases, so you won't see that all the time. All right. Last but not least is horizontal asymptotes. Very similar to vertical asymptotes is how they act, but finding them is a little different. Okay, so what we need to do is look at the highest degree, Murray, come on, typo, highest degree of the exponents in the numerator and denominator. And we're going to use Bobo Botten eats DC. Okay, this is new for me, so Murray is the expert, but I'm going to try my best to teach you guys. Okay, so Bobo, okay, which means bigger exponent on bottom. Okay, so if we're looking up here, we've got x to the first power divided by x to the second power. Okay, the bigger exponent being 2 is on bottom. Okay, so what you use is the value at the end here. Now we have a plus 0, so that is the thing that we use. So we would just set y equal to that number, 0. So that is your horizontal asymptote, only when your exponent is bigger on bottom. Okay, now the next one, Botten, okay, if the bigger exponent is on top, you don't have a horizontal asymptote. Okay, they don't exist there. So once again, if we take a look, x squared and x squared is bigger on top. We do not have a horizontal asymptote. What we have is called a slant or oblique asymptote, and we actually use long division to figure out what it is. If you are in K with us right now, just understand you long divide this problem, and any remainder that you have is tossed away, and you use everything else as your equation for your slant asymptote. Okay, we'll talk about that later in case you are confused. But the last one is eats DC. Okay, so exponents are the same. You divide their coefficients. Okay, so let's take a look. We have an x squared up front and an x squared up front. they are the same exponents, so you divide the coefficients. Now, what coefficients do we have in front of the x squared? We have a 1, and on bottom we also have a 1. Okay, if they were any numbers like 4, whatever, you divide them. So simply put, this one we're going to divide 1 by 1. 1 divided by 1 is 1. So y equals 1 is our horizontal asymptote. Okay, pretty straightforward with all three of these. Just got to remember Bobo Button eats DC. Okay, last thing. Your function can cross your horizontal asymptote one time. So don't be surprised if it crosses it and you're like, what? Asymptotes shouldn't do that. Okay, vertical asymptotes will never cross. Horizontal asymptotes can cross once. Okay. Ladies and gentlemen, if you are confused, once again, always ask your teacher for help. They are more than willing to help you. If not, watch this video again. Look at the other videos. Maybe you'll get some other ideas to help you out. Hopefully we have answered all your questions. If not, we will try to make more videos to help you guys out. But I think that's it. What, Murray? She's talking crap. Okay. All right, ladies and gentlemen, have a good rest of the day and learn some more math. Bye.